means or equal to, it's worth spending some time, you know, memorizing these, for lack of a better idea here. But they are solved. They are solved much the same way that we've been solving problems now. So there's a few exceptions we'll get to, but these are the first things to have down. Let me know when you got these down, and we'll go on to some questions now.
Okay, I think I'm ready.
All right, so again, kind of a new problem here. Let's say it's like x divided by 3 minus 4 greater than -1. Okay, to solve this, you would undo the subtraction by 4. All right, so you would add 4 to both sides. On the left, you have x divided by 3 greater than 3. To undo this division by 3 on the left, you multiply both sides by 3. All right, and so that becomes x greater than 9.
What does the -1 have to do with anything?
It's just a problem that I came up with. Doesn't have to do with anything. It's just to start. Okay, so let's try another one here. Let's say that it's 2x plus 5 less than or equal to 17. Okay. How would you solve this? What's the first thing to undo?
I don't know.
Well, let's say it was 2x plus 5 equals 17. What would you do?
I don't know.
Okay, well, this is what we covered last time. No idea. I mean, I don't think it's a good use for our time to repeat stuff, but we can. So you undo addition and subtraction before you undo multiplication and division. So when you look at the side with the variable, here, which is on the left, you've got multiplication by 2 and then addition by 5. So which do we undo first?
5?
The addition by 5. So you're gonna subtract 5 from both sides. In the previous problem, we undid the subtraction first. So you always undo addition and subtraction. In the problem before that, we undid the subtraction. You always undo addition and subtraction before multiplication and division. So in our current problem here, 2x plus 5 equals 17, or less than or equal to 17 produces the same thing. You have 2x less than or equal to 12. Okay, so we have to undo this multiplication by 2 by dividing by 2. So x is less than or equal to 6. All right, so this is a good point to talk about what does this actually mean? Like, what does it mean for x to be less than or equal to 6? So imagine a number line. Number line extends forever in both directions, from -infinity to infinity. And let's just say a lot of students like to start at 0. It's not necessary, but now we'll go at 1, 2, 3, 4, 5, 6. There it's 6. Okay. So in words, this means all the numbers to the left of 6. All the numbers to the left of 6. But you also include 6. So that line underneath means less than or equal to. The equal to means it can be 6, and it means everything to the left of 6. Everything to the left 6. So graphically, less than or equal to means put a dot on the 6 and graph the left. All right, so that's kind of where we're going. We want to be able to graph these, but let's just focus on solving them. So let's do another one. Let's say it's 4x minus 7 greater than or equal to 35. Sorry, 28. Sorry, 21. All right, 4x minus 7 greater than or equal to 21. So you first undo addition and subtraction. What should you undo first over here on the left?
7.
How do you undo it?
You add something? I just don't remember what you add.
So you always add the number. If you look back at all the examples we did, you're always adding the number, but in this case, it's -7, so you add 7. So 4x is greater than or equal to 28. And then you divide by the number that you're multiplying by. X is greater than or equal to 7. Right? So now again, like if we were to go to a number line and the number line extends infinitely in both directions, and you say, okay, there's 0, where's 7? 1, 2, 3, 4, 5, 6, 7. There's 7. You put a dot there. This again means all numbers to the right. So the greater than or equal to tells you it's to the right of 7, but it also includes 7 because of that equal to. It means start at 7 and go to the right forever.
Okay.
Okay. So a few other things to think about here. If I write this, I'm saying x is greater than 1. This is x greater than 1. Okay. X is greater than 1. All right. Notice the variable is on the left. In every problem we've done tonight, the variable has been on the left. Variables on the left. Variables on the left. There's a reason for that. We read left to right. You write math expressions left to right. So when you put x greater than 1, that's correct. Now you may work out a problem later on here where you get 2 less than x like this. And while this is correct, it's the wrong preference. It's like if you wear a shirt inside out, you have a shirt on, but you probably want it to be not inside out. It's kind of the same thing here. Like this is not correct. It's correct, but it's not the way you want to present your answer. So you always want the variable on the left. This is the correct way to present your answer. X greater than 2. Now, what I want you to focus on, look at where the variable is and look at the direction of that inequality. You see how kind of the open end is on the X and the pointy end is on the 2?
Mm-hmm.
The same thing exists here. The open end is on the X, the pointy end is on the 2.
Whatever is on the end that's open is the bigger one, right?
Well, it's got to be consistent.
Or
So
equal to.
yeah, so we'll do another one here. Like let's say you get -1 greater than or equal to X. This time it's X less than or equal to -1. So see how it's pointing at the X this time? It has to point at the X still.
Oh yeah, what's the difference?
They're the same, but the one on the bottom is the preferred way to write your answer. You will only see answers this way on your test. So it's like if you
So
work out
only
a
with the
problem,
variable first?
yes, the variable has to be first. So let me give you an example here now to see this. Let's say it's 5 greater than -2 plus x. Okay, something very straightforward. So to solve for x, you have to undo this -2. How do you undo -2?
Add 2?
You add 2. So your answer, this is your answer. But the problem is your multiple choice answers will not have that. So I'm going to write 2 possibilities here, and you tell me which one is correct. Is it A or is it B?
B? Or
It's
no,
B.
wait, I forgot. Oh, it
So
is right.
it is,
I wasn't looking
well,
at the signs or the answer. Sorry, I got distracted and I thought you just meant which one was first, and I said the first one I saw because it had X in first.
that's okay. That's okay. The reason B is correct is because it's pointing at the X. It's pointing at the X. They have to be the same. All right. So let's give you one to try here. Let's go 3 less than or equal to 2x minus 1. All right. So why don't you try solving this and let me know if you have any questions.
I don't know.
Okay. Look at the side with the variable 2x minus 1. Which do you undo first, the multiplication or the subtraction?
The one, but the 3's on the other side of it. Do you add the 1 to the 2x? I forgot. Or
You
do you
always
add the
add,
1 to the 3?
yeah,
Oh, so
you
I was
add.
gonna add it to the 2x.
Well, you envision kind of there's a like a wall or a border there, and you're trading. So you're trying to you're doing it to both sides, or so does that maybe help to give this one a try? Finish.
And would -1 plus 1 just be 0? Two?
So I'm looking for an inequality, like got it, you've got to have a variable in there, less than, greater than, less than or equal to, greater than or equal to.
It's less than 2?
Give me something like
X is less than 2?
x is less than 2, like this. That's what you've got here. So 4 less than 2x, then divide by 2. So you have 2 and then this symbol and an x. Are these the same? Do these look the same to you?
No, X is greater than 2, but I got X
Yes.
less than 2.
Okay. Let's try another one here. Let's go.
Do you just bring down the symbol? Would that put the
Yes.
2 before the X?
You just bring it down until the last when you're ready to decide if it's in the right order, because you really want the variable you really want the variable on the left. So if it's on the right, you wait till the end though to make that change. Let's try another one. Let's say it's -1 greater than -5 plus 2x. Nope, sorry, I don't like these numbers. Let's try something different. Let's go -13. Let's do that. -13 greater than -5 plus 2x.
But I had 13 or 5.
So you always look at the side with the variable. You undo addition and subtraction before multiplication and division. So in this case, you're going to undo -5.
Four greater than X?
Is this something? Is this is what you have
-4
here?
greater than X?
I'm just asking, just making sure, because the language is kind of the big barrier on these. A lot of students will maybe have the right thing on their paper, but not say the right thing. And I don't want to,
Yeah,
want to
that's
make
what I
sure
have
that,
on the paper.
okay. All right. So this is fine, but the variable needs to be on the left. So how would you change this so that the variable is on the left? What would go after X? What symbol?
Just flip the symbol.
Okay.
I
All right. So
guess it's
let's
small.
double check here. Add 5 to both sides. -8 greater than 2x. Divide by 2, divide by 2. And then like you said, yes. Okay. Good. All right. So a couple of short questions here before we close out. Is -4 less than -5? Is this true?
No,
So it's a true false situation, right? So it's easy to sort of guess here. It's
because would a
always good.
-5 be farther from -4? Like it would be -1, -2, -3.
Exactly. So you're looking at like, where are these on the number line? So is -4 less than -5? It is false. Okay. All right. How about this? Is 3 greater than or equal to 3?
Yeah,
Is this
true.
true or false? True. This is true because they are equal. They're absolutely equal here. All right. So here's another one. Is 2 less than -2?
False.
This is false. Okay. So these are not necessarily questions you'll get, but you want to sort of know. So this leads to kind of the next type of problem, which is I give you an inequality like 5x minus 8 greater than -3. And I ask you, is x equals -1 true? Okay, like does that work? Is that a solution? So the way to do this is to substitute that number in. 5 times -1 is -5 minus 8. So is -13 greater than -3?
True.
Is this true? Is -13 to the right of -3?
False.
Yes, this is false. Again, it really comes down to like,
No, I
can
thought you said it
you,
was. I thought you said it was greater. Isn't the greater sign on the -13?
you're asking about the two numbers. You're saying where are they in relation to each other? Is -13 greater than means to the right? Is -13 to the right of -3? So it
But
is
that's
the
the
case,
greater than sign. That's the
right?
less than pointing towards the 3.
Greater than by definition means, if you want to look at it another way, it's which is more to the right is what it's another way to view it. The correct statement is that -13 is less than -3, or to write -3 greater than -13.
Oh, so you just wrote it backwards? I thought you were just asking what
No,
was which
I did
one was
not.
under the bigger symbol.
I did not write it backwards. I just writing down the steps in the order here. Like this is a question. It's like, is this true? So you just work it out and then you make a decision at the end. And you're just asking, like, is this true? That's all it is. Is it true? It doesn't mean that as it's written, it's true. It means like, is what you got as a result of doing all this? Like, this
But
is the
why?
result.
But would that also be the correct answer? I don't get it.
No, this is not the correct answer. This is
Oh,
false.
I thought you were writing down the correct answer.
These are the correct
But
answers down here. These are both true.
that's what I meant by backwards. I thought you were. I didn't know you were writing out like a not right question for true or false. I thought you were writing out something and then asking true or false about something totally different.
Just to reset here, I was providing an inequality and asking if this was a true, if this number works. Does this number make this true? And so there's what's called a proof by contradiction, which is where you assume that it's true and work it out, but it leads to a contradiction. Now, you don't need to know that, but that is what this is. And so the question is like, does it end up producing something that is true? No, it does not. So therefore, this is false. What is true is that -13 is less than -3, and -3 is greater than -13. All right, so we're going to go ahead and stop there for tonight.